Hello students, in this video we will solve the third problem of the chapter Gravitation from Concepts of Physics by H.C. Verma. In this problem we have three equal masses, each of them is equal to small m and they are placed at the three corners of an equilateral triangle. Length of each side of that triangle is given as small a. So first of all, let us consider an equilateral triangle, say ABC. Now we have three equal masses and they are placed at the three corners and it is shown in the figure. Now according to the problem, we have a fourth particle of mass m and this fourth particle will be placed in the first part of the problem at the midpoint of any side of this equilateral triangle, and in the second part of the problem this fourth particle will be placed at the center of the triangle. In both the cases we have to find the total gravitational force exerted by the three masses placed at the three corners on that fourth particle of mass m. So first of all, let us solve the first part of the problem. To solve the first part of the problem, let us consider the midpoint of the side AB. We mark this midpoint as P. Now we will place the particle of mass m at point P. Now we will calculate what is the net force acting on this mass m placed at P due to the three masses at the three corners of that equilateral triangle. Now, according to the problem, we can write AB is equal to BC is equal to CA and all of them are equal to small a because it is an equilateral triangle. Now, we have considered P as the midpoint of the side AB. Therefore, we can write AP is equal to BP and that is equal to A by 2 because AP and BP will be equal to half the length of the side AB. So we have the distance of the point P from the two corners A and B. Now we have to calculate the distance of the point P from the third corner, that is corner C. Now according to the figure, CP is the one of the three medians of this equilateral triangle. So we need to find what is the length of this median. Remember, for an equilateral triangle, length of all the medians will be the same. So the value of CP will be equal to root 3 by 2 times the length of any of the three sides of that equilateral triangle. So CP will be equal to root 3a divided by 2. So we have the distances of this point P from the three corners A, B and C. AP and BP is equal to A by 2 and CP is equal to root 3a by 2. Now, to find the total gravitational force exerted by the three masses at the three corners on the particle of mass m placed at P, first of all, let us calculate what is the force exerted by the mass m at A on the particle placed at P. Let us denote this force as F suffix PA. So F suffix PA denotes force exerted on the particle placed at P provided by the mass placed at A. So according to Newton's law of gravitation, we can write this force is equal to G m into m divided by distance AP square. AP is equal to A by 2. So if we substitute AP by A by 2, the magnitude of the force will become 4gm square divided by a square. So this is the magnitude of this force FPA. Now what about the direction of the force? It is a gravitational force. We all know that gravitational force is attractive in nature. So the direction of the force will be from P to A. So the direction of this force is from P to A. Now we will calculate the force exerted by the mass at B on the particle placed at P. So let us denote this force by F suffix Pb. So F suffix Pb represents force exerted on the particle at P provided by the mass at B. So F suffix Pb will again be equal to Gm into m divided by, now it will be the distance Bp square. Bp is again equal to A by 2. So substituting Bp by A by 2, we get the magnitude of the force as 4gm square divided by A square. Now again it is an attractive force, so the direction of the force will be from P to B. So the direction of the force is from P to B. So we have the two forces. Now we need to calculate the third force, that is the force exerted by the mass m placed at C on the particle placed at P. So let us denote this force by F suffix Pc. So F suffix Pc represents force exerted on the particle at P by the mass placed at C. So it will be equal to G product of the two masses, that is m into m divided by Cp square. Now Cp is equal to root 3 a by 2. So if we substitute Cp by root 3 a by 2, then the magnitude of the force will be 4gm square divided by 3a square. Again it is an attractive force, so the direction of the force will be from P to C. So this will be the direction of the force F suffix Pc. So the direction of the force is from P to C. So we have three forces. Now if we follow the magnitude of these three forces, then we can find that, or we can say that F suffix Pa and F suffix Pb, these two forces are equal in magnitude, but according to the directions we can say they are oppositely directed along the same line AB. So if two equal forces act along the same line in two opposite directions, then they will nullify each other. So FPA and FPB will nullify each other. So the net force that will be acting on the mass placed at P will be exactly equal to that third force, that is F suffix Pc. So we can say that F suffix Pc, F suffix Pa and F suffix Pb, since they are oppositely directed, so they nullifies each other. So we can say, since F suffix Pa is equal to F suffix Pb, that means these two forces are having equal in magnitude but oppositely directed, therefore they cancel each other. So if FPA and FPB cancel each other, so the net force which will be acting on the particle placed at P, that is F net on the particle placed at P will be simply equal to this third force, which was F suffix Pc. So F net at P will be equal to F suffix Pc, that was equal to 4gm square divided by 3a square. So this will be the magnitude of the force, and the direction of this net force will be from P to C. So this is our answer to the first part of the problem. Now remember one thing, we can choose the midpoint for any of the three sides. So if we consider the midpoint of the side BC, then using the same logic we will find that the net force which will be acting on the particle placed at Q will be directed from Q to A. So if we consider the midpoint of the side BC, then F net at point Q will be equal to the force which will be acting from F Q to A. So this F net at Q will be equal to F suffix QA. The magnitude of this force will be exactly equal to the force or net force acting on the particle placed at P. So it will again be 4gm square divided by a square. Now the direction of the force will be from Q to A. Why? Because AQ is the second median of this equilateral triangle, and we have already stated that for an equilateral triangle, length of all the medians are same. That is why we will get the net force on the particle placed at Q is exactly equal to the net force acting on the particle placed at P. In the same way, if we consider the midpoint of the side AC, then F net for the particle placed at point R, which is the midpoint of the side AC, the magnitude of this force will be exactly equal to the force F suffix RB. So it will be directed from R to B. Again it will be equal to 4gm square divided by 3a square, and the direction of the force will be from R to B, because BR is the third median of this equilateral triangle. Since it is an equilateral triangle, so see, you can take the midpoint of any of the three sides of the equilateral triangle, and in all the cases the net force acting on the fourth particle due to the system of masses will be exactly equal in magnitude, but their directions will be different. So this is the first part of the problem. Now we will solve the second part of the problem. Now in the second part of the problem, this fourth particle is placed at the center of the equilateral triangle. Now what is the center of a triangle? Center of a triangle is the intersecting point of all the medians of the triangle. So for this given equilateral triangle ABC, we have the medians AQ, CP and BR according to the figure. So the intersecting point of AQ, CP and BR will be the midpoint of this equilateral triangle. So if we mark this point or intersecting point as O, then O will be the center of this equilateral triangle. Now according to the geometry, O is nothing but the centroid of this equilateral triangle. Now we will place the mass, that is the fourth particle, at O, and we will be calculating the net force acting on this particle of mass m placed at point O. Now we know that from geometry, O, that is the center of that triangle, is the centroid of the triangle. So first of all, let us calculate the distance of this central point O from the three corners of that equilateral triangle. We know that for an equilateral triangle, length of all the medians are same. So we have the medians AP, that will, sorry, not AP, let me erase this part. So it will be the median AQ, the median CP, and the median BR, and they are all equal to root 3a by 2. We know the length of each median of this equilateral triangle. Now what will be the distance of this point O from the three corners A, B and C? It is an equilateral triangle, so the distance of the centroid from any corner of the equilateral triangle will be the same. That means if we calculate OA and OB and OC, all of them will be equal in magnitude. So the distance OA, OB and OC are the same. Now what about the distance? Remember, the distance of the centroid from any of the three corners of the equilateral triangle is 2/3 of length of any one median of the triangle. So it will be 2 by 3 into root 3 by 2 into A. So if we simplify, 2 cancels out, so we get root 3 by 3 into A. That means it is equal to A by root 3. Therefore we can write OA is equal to OB is equal to OC, and they are all equal to A by root 3. So this is the distance of the centroid or center of that equilateral triangle from all the three corners of that equilateral triangle. Now we will calculate the total force exerted by the three masses on the fourth particle placed at O. Now first of all, let us calculate the force exerted by the mass m placed at A on the particle placed at O. So let us denote this force as F suffix OA. So F suffix OA represents the force exerted on the particle placed at O provided by the mass placed at A. So F suffix OA will be equal to, according to Newton's law of gravitation, Gm into m divided by OA square. OA is equal to A by root 3. So if we substitute, we get the magnitude of this force as 3gm square divided by A square. So this is the magnitude of the force F suffix OA. Now what about the direction? It is a gravitational force, so it will be attractive in nature. So the direction of the force F suffix OA will be from O to A. So this is the direction of this force. Now similarly, we will calculate the magnitude of the force exerted by the mass placed at B on the particle placed at O. So let us denote this second force as F suffix OB. So F suffix OB represents force exerted on the particle placed at O provided by the mass placed at B. So it will again be, according to Newton's law of gravitation, gm into m divided by distance OB square. OB is again a by root 3. So substituting, we get 3gm square divided by a square. So this is the magnitude of the force FOB, and again since it is an attractive force, so it will be directed from O to B. So this will be the direction of the force, that is O to B. Now we will be calculating the third force, which will be provided by the mass at C on the particle placed at O. So F suffix OC, this represents the force on particle placed at O provided by the mass placed at C. So F suffix OC will be equal to G, again product of the two masses, that is m into m divided by OC square. OC is again a by root 3. So substituting, we get the magnitude of the force as 3gm square divided by a square. Now the direction of this third force will be from O to C. So the direction is from O to C. Now consider the magnitudes of these three forces, FOA, FOB and FOC. All of them are equal in magnitudes, but they are acting along three different directions. So we need to find the resultant force or the resultant of all these three forces. So we have a situation like this, where one force is directed in this way, it is F suffix OA. The one force is directed in this direction, which is F suffix OB, and the third force is directed in this way. So we have three equal forces and they are directed in three different directions. So we need to find the resultant of these three forces. So to do so, first of all, let us only concentrate on the two forces, that is F suffix OA and F suffix OB first. So this is the situation. F suffix OA and F suffix OB. We will be calculating the resultant of these two forces first. So what about the resultant of FOA and FOB? So first of all, calculate the resultant of FOA and FOB. Let the resultant is represented by F prime. So F prime will be equal to under square root, it will be FOA square plus FOB square plus 2 FOA FOB cos theta. So we need to know what is the value of this cos theta. That means the angle between these two forces. Remember, whenever we will be calculating the angle, this angle will be equal to 120 degrees. So 120 degree is the angle between FOA and FOB. In the same way, the angle between FOB and FOC will be again equal to 120 degree. and that between FOC and FOA will again be equal to 120 degree. So for these two forces FOA and FOB, the angle is equal to 120 degrees. Now magnitude of FOA and FOB is the same. So we can write, let FOA is equal to FOB is equal to FOC. All of them are equal in magnitude, which is nothing but 3gm square divided by a square. Let all of them are equal to f. So what will be the magnitude of f prime? So f prime will be equal to, if we substitute FOA and FOB by this f, then it will be under square root 2f square plus 2f square into cos 120 degrees. The magnitude or the value of cos 120 degree is equal to minus half. So we can write f prime is equal to under square root 2f square plus 2f square into minus half. Now if you simplify, you will find f prime is equal to f. That means the resultant of FOA and FOB is equal in magnitude as that of either FOA or FOB. So f prime can be written as 3gm square divided by a square. So we have a situation where we have f prime, which is the resultant of FOA and FOB, whose magnitude is equal to 3gm square divided by a square. Now what will be the direction of f prime? Since FOA and FOB are equal in magnitude, the resultant f prime will bisect the internal angle between FOA and FOB. So FOA and FOB was directed along OA and OB. So f prime will be directed along OP. So the direction of the f prime will be according to the figure from O to P. Now we have the third force, which is acting along the same line from O to C. So we have the third force F suffix OC, which is of the same magnitude, that is 3gm square divided by a square, and it is acting from O to C. So finally we have a situation where from point O, f prime is acting from point O to point P, and FOC is acting from point O to point C. These two forces are equal in magnitude and they are acting along the same line CP in two opposite directions. So they will nullify each other. So we can say f prime, which is the resultant of FOA and FOB, and the third force FOC, they cancel each other because they are equal in magnitude but opposite in direction. So they cancel each other. So if these two forces cancel each other, then we can say that net force acting on the particle placed at the center of the triangle is equal to 0. Therefore, net force acting on the particle placed at O is equal to 0. This is 0. So this is our answer to the second part of the problem.